Hello everybody, I'm Rhys, or ARJ on the forums. My main focus is all on browser things, but looking at how preservation for all things into the browser is a particular kind of interest. And today I want to talk about BeebEm in the context of Domesday. So all of this is in relation to the Centre for Computing History's recent put up of the emulator up on their servers. So what I'll do is I'll start my screen share here, and what I'll do is, if you can see that, there's a kind of a core element of what I want to talk about. But first of all, if you are watching this now or later on, I encourage you to go to the Domesday Computer History .org UK site, because you can actually run everything I'm talking about today directly in your browser. And that pretty much is the purpose of the talk. It's how do you get to what you'll be using directly yourself. But the two main themes, if you like, of what we'll be talking about is digital preservation, which makes sense, but equally important is maintaining public access. And I think because it's relating to the Centre for Computing History Museum, that's an important part of the message. And in fact, without the museum being there, you couldn't be in a position where you could actually at home experience the Domesday system directly from your browser. They are especially positioned to be able to do that. And, you know, if you find it useful and they're doing wonderful stuff, I'd recommend you, you know, help them out. It's a good thing to do. So I'll spend a few minutes kind of going through the preservation side and how to give access. The two main elements of what I'll be talking about is BeebEm, why BeebEm, and what I added into BeebEm, and also how you actually give access and what that means. And I'll be touching on WebAssembly, which is a new technology that is browser-based and has quite a far-reaching kind of meaning in terms of what you can achieve now in terms of archiving and giving access to things. Now, you might ask, you know, why Domesday? It does come up from time to time as to why has this got a captivating interest for many of us? And I think, for me anyway, one of the core elements is that it's a precursor to so many technologies that we take for granted these days, things that we use, you know, day in, day out, either from the kind of crowdsourced or user-generated content stuff that we all consume and contribute to. I think mapping as a first-class interface into how you explore data, and you know, now everybody uses Google Maps or Apple Maps or whatever else without thought. Back then, it was a kind of innovative kind of interface, and you can take that as well to the Street View kind of experience that you can have walking around Brecon and a few other, you know, there's a farm you can walk around. Again, having that 360 kind of, you've got agency of exploring this virtual space, again, very groundbreaking. And to top it off, you've got full search and all of that in a capsule of that time frame. I guess the only thing that was missing in all of that was kind of networking. I think, you know, that was the difference between maybe then and today. So that is an interest of Domesday. I think there's a secondary interest as well from my point of view, which is the history of archiving, because quite often what you'll find is that you know, you read about a worry from Domesday disappearing because of the disks rotting and all the rest of it. And probably about 20 years ago now, that there was an initial kind of project to try and make sure that this information is not lost. And what's interesting now is the time between then and Domesday being published is kind of shorter than between now and when that task was starting. So we've now got this kind of meta reflection on how do you look at projects that try and sustain archive and keep things going. And you can reflect on that in Domesday by seeing things that are initiated, they succeed, but then they don't continue for different reasons. Some of them are to do with technology being available and then not being available. Some of them purely because, yes, it's archived, but it's locked away with the National Archives. Others are a little bit more tragic, where the people involved are no longer here. Sadly, Adrian Pierce has kind of passed away. And then others are more, maybe a bit more head scratching. Things like BBC got involved with the Domesday Reloaded and made things available with a good web interface. But again, that was archived itself in 2018 and is now in a place that is not really accessible in a functional way from what it was before. So I think this is quite interesting because, and I think in previous videos from Simon Innes and on ABug, where you find that this approach of archiving is only half the story, because if you don't give kind of access to that, then it kind of defeats the issue. So looking at where we are today, there's kind of two major initiatives. You've obviously got the wonderful kind of resource that's going on with the Domesday 86 crew, where the preservation and recreating that experience is the main kind of thrust. What I'll talk about in here is, from the Centre for Computing History's point of view, is how do you get that access to that through emulation. So emulation very much is the topic. So again, just preservation and maintaining access. If I take each one of those in turns, I'm not going to talk about the actual archiving process. That has been covered. There's lots of really good activity there in terms of the Domesday 86 and activity on the Laserdiscs, being able to take the analog and the digital information of that. There are also other past projects that have happened, both at the museum, BeebEm. There's lots of people who have been looking at their own Domesday system and how you can actually extract that information. What I'm interested is in how do you recreate the runtime environment to experience it. And there are two kind of approaches, as you could think. You can look to replicate the hardware, and I think that's the closest to the truth, as it were, of ensuring that the system continues to exist and you can actually engage with it as it was and get a real experience. But in terms of reach, I think software emulation also has a role to play, because it means you can actually give something that somebody can consume straight away. There's no kind of dependency for bits of hardware to get going. So in looking at kind of how do you give access, I think looking at why some of the previous efforts fail, it's mostly because they have gone away for some reason or other. So having something that is standards-based, that isn't complicated, as simple as you can be, can run as wide as you can on different platforms, and most importantly, has more than just you maintaining the thing. It is kind of the list of the requirements. And the thing that tops all of that is the web. It's the thing that you give it a website from 25 years ago, and you can still use a browser today to view it. And I would gather a guess that in another 25 years' time, you'll still be using a browser in some capacity to actually work with, consume and engage with data and apps. So my talk is about, really, okay, we've got something to do with Domesday we want to keep. We want to use the web as a method of preserving, emulating and delivering access to that. So the question I asked was, what's the best approach here? And I was looking at different BeebEm emulators and really had two questions in my mind. It was, can it emulate Domesday, and will it work in a browser? And the great thing about kind of the different BeebEm emulators out there, each one had a yes in different capacity to each one of those questions. I know the previous work on the Domesday emulation had used BeebEm, so I knew that was technically possible. And obviously the fantastic JSBeeb works really good in the browser. So I'm thinking, well, let me look at how close each one of those is. And I did a little table and looked at what the requirements were. I quickly honed down on BeebEm. This is an example of this table where I looked, does it emulate the Master 128? Yes, the coprocessor. Can it run the ROM that runs the VFS, the file system of Domesday? Things like the trackable, which is like the mouse support, and SCSI, all of those were ticked yes. There's no LV-ROM or the bit that drives the disk in Domesday support, and it doesn't work in the browser. Looking at other things like JSBeeb, it did most of these things in the same way. It didn't have, at the time I was looking at it, trackable support or SCSI support, but it runs in the browser. So both were kind of equidistant to where I wanted to get. Now that basically started a side project. If the Domesday thing was the first side project, this was the second kind of internal project with that, which is, well, can you take BeebEm and make that work in the browser? Because that would get you closer to where you want to be. Quite a lot of things work in the browser. And when you're thinking about these things, you have to kind of disassociate yourself from maybe the forms and the stuff that you work on normally and browse away to applications that run in the browser. And the two examples that kind of thinking about them now, there are systems complete like Windows 2000 could work in a browser. There is a whole set of archived or old flight simulator, Microsoft Flight Simulator, full binaries working on DOS, running in a browser, and both of these work pretty well. So being able to sort of think about taking sort of C binary code and running it in a browser is quite a valid approach to take. So I'll be talking now more about that process, if you like, for a little while, and then specifically in the context of BeebEm, because if you want to run something in your browser, you've pretty much got two options. You can either take the code and change it into JavaScript, which is the language that runs in the browser, and this is effectively the JSBeeb approach. The other one is you kind of keep everything in your language of choice, so it'll be C, C++, or whatever the language it's currently written on, and then you recompile it, but run it in a runtime that is in the browser. That could be JavaScript or something else. So this process of recompiling is quite an interesting one, because it's something that in many different technologies has been used, because if you split up the parts of compiling something, then you can kind of share the burden a little bit about who does all the hard work in each stage. And one of those technologies that I'm sure quite a few use is LLVM, which is this kind of low-level kind of virtual machine thing, which allows you to have this target environment that you can compile to, and then you optimize and do very clever things on there, and independently generate an ARM binary or generate an Intel binary or whatever type of binary that you want for your runtime. And of course, if you've got that infrastructure in place, it's a small step to say, well let's make the web a runtime. And over the course of many years, and this is like just a timeline of the last 20 years or so, the move of making the browser a proper kind of computing runtime environment has grown immensely from something that was inconceivable, in the slow JavaScript era of kind of, in the early kind of noughties. The version of V8 that was brought into the browser allowed the performance to be such that you could actually envision now running proper applications in the browser. And the main thing I'll be talking about today is WebAssembly, which is the progression of that in a way that allows you to run a kind of a virtual environment in the browser and targeted from an output of LLVM. Now some of you are already using WebAssembly as we speak, because Zoom itself uses WebAssembly for the video encoding if you're viewing this in the browser. So it is pretty ubiquitous now, and conceptually it's quite straightforward. It's allowing you to take existing C code and compiling it into the WebAssembly format. WASM is the kind of short term for it. And then with some JavaScript environment in your browser, it runs and you can interact with it there and then. Now, there are other runtime environments for it. I'm not going to cover those today, but they run on edge computing and different places because it's a very nice kind of sandboxed environment. I'll encourage you to kind of go and read more about it kind of from the links that I'll be giving from this, because it's quite a fascinating kind of development. And the simplicity of it is quite nice in that the WebAssembly, it's literally just a chunk of memory. It only has a few types, which is 32-bit ints, 32-bit floats, and 64-bit floats as well, and pretty much that's it. And all you do is you write something into the memory, you call a function, it does something there, and it writes back into the memory, and then you read from that. So it's quite a straightforward, safe element, which is appealing for many use cases in the browser. What that means, of course, is you can then put your code into LLVM, generate the output WASM code, run it in your browser, and then hook different functions from it and poke out into the real world from within there. All sounds quite complicated, but luckily the tool chain has come a long way. There is a project called Emscriptum. It basically sits alongside LLVM. It allows you to run C, C++ kind of compilations, but it also has all of the tooling around that, things like the configuration and the make files, so that you can actually have a whole kind of normal build process that you would normally have, say, in the Linux box. Now you can run and target the web in a very similar way. So I had, well, I read this, of course, yes, why not? Download BeebEm, you know, set it up on the box, follow the guide, run emconfigure andemmake, and it should work. And I think the surprising thing was it was very close to working. The two things that are missing, if you know BeebEm, it's got a menu system that's in a library called GTK, and it does its graphics using SDL, which is like this way of drawing things on the screen. There are two versions. It used version 1, and Emscriptum only had version 2. That was close enough to think about doing a quick change and progressing to see if that was a possibility. And some of the changes are quite cosmetic. You change, you know, one function call is slightly different. The biggest change is to do with how you set up a screen and how you actually create the interfaces to it. And again, SDL is just a library of how to do kind of 2D graphics. Emscriptum and WebAssembly then maps that onto a HTML canvas for you in the background, but it's still kind of pixels being blitted around. And with those two things addressed, you finish the compilation. It gave you a HTML file. You point your browser to it, and hey presto, it boots up. And that was quite a bit of a surprise, because I thought it would be a little bit more difficult. But because BeebEm, certainly the Linux one I was basing it off, which is 0.013, it uses, you know, a standard POSIX kind of environment it's expecting, and Emscriptum gives you most of that POSIX environment. It's got an emulation of a file system. It's all in memory, but it means when you are looking for your, you know, your ROM to put in, you just read that in, and it does that for you in memory, translated through to the fopen calls in C. So it's a very good established toolchain, and I would say recommended for many projects. It does allow you to hit the road running very, very quickly. So back to that table. Now I've got a tech in the box for running in a browser. So now this kind of position of how close is it to take something and you know, Domesday and run it in the browser gets quite close. The bits that are missing, the LV-ROM and the genlock, I mean, I was looking at the previous information out there, and there are some older things from the Chameleon projects. There's you know, the guide itself that talks quite in some detail about how the system works, and you can kind of prod inside a box to see what the connections are. Of course, now with the whole resource on Domesday 86, it's such a rich kind of resource of what's there. The whole kind of element is quite clear to be able to re-implement in software. But the actual approach I took, and I'm putting this code on the screen just to show you how close it was to BeebEm, from what BeebEm did in SCSI to effectively what the LV-ROM, the bit that drives the disk off the master, is pretty much like for like. So I was able to take the SCSI code, rename it to LV-ROM, and again, try and get something working up on the screen. The thing that was missing more than anything was being able to kind of hook in the read and the write. Now, in terms of the mapping of the space in the BeebEm's code, it basically sits in the same place as the 8271 FDC, and then you just tell it to go and read the stuff off the disk. It was, again, quite straightforward. But looking at the way that was booting up, it didn't get very far. And that essentially is down to these use of these F codes. In other words, the thing itself has a storage of data, and it also wants you to display things on the screen. And those are done using F codes over the kind of SCSI layer. And you need to respond to that in the right way. So there's a little bit of toing and froing there to actually get it to recognize the right F code and the responses. Again, a lot of it is semi-documented, and it's a case of implementing them. But once the core of that is up, then all of a sudden it will boot and it'll mount the LV-ROM data, and you'll get this screen. I remember seeing this and thinking, gosh, it's actually worked. This is the BeebEm loading in the contents of the, I think it's the Community South disk, again, in a browser. And yeah, Stardot gives you a magical feeling when you see what you expect up on the screen. Now, that's kind of given us, BeebEm in a browser, LV-ROM reading a disk in the browser. We're kind of getting close now to something that is usable. The thing that is missing is this thing of taking the disk output that's normally kind of analog, which is the picture or the video, and it overlays it with the output of the Beeb, and it throws it up on the screen. So in software, we'll need to do something similar. And we know the commands that are sent out to go to this frame, in other words, show this picture, or go to this frame and start playing video. We can translate those quite straightforwardly, and the web, it's quite natural to deal with these things. So what I did is looking at how we could actually structure a background layer in the browser, again using SDL as the way of controlling things, and a bit of a JavaScript link. Because again, with WebAssembly, you can do most things in the language of your choice that's compiled to WebAssembly, but with a function table, you can still say, I want to call some JavaScript, or JavaScript wants to call some C, and it allows you to do this little kind of handshaking things. So by putting something that says, when I'm being told to go to a certain frame, can you go and load this image for me? And then can we kind of put it in front with or behind, depending on what I tell you to do, on the canvas element in the browser. I can then pass things back into BeebEm so it can bitblit its content on the screen every frame. And again, quite a straightforward logic piece to do, and it's reasonably similar to what is actually done in hardware if you look at the kind of logic flow of it. And hey presto, that then works. It allows you to have the image loaded in, displayed in the browser, and then BeebEm to then do its normal thing of rendering things to its frame buffer, and that being applied on top of the image that's then shown. And again, that's a fantastic endpoint. It means now this is doable, it runs. But if you take, again, a step back, I mean, we're just following the same thing that the previous kind of projects have done. We've got something that runs, works with an emulated Domesday system, but again, this is on your bench at home, or at the museum, or it's in a specific place. The actual access to it is still limited, and if you can't have a way that allows you to give access, then the purpose of maintaining these things is somewhat kind of diminished in terms of the value that it gives. And certainly in the context of a museum, that is the purpose of being able to archive things and also give public access so people can learn and experience these things. So the final part of the work was thinking, well, okay, we've got the whole kind of Domesday system loaded into this WebAssembly thing. How do we make it so that we could give access remotely to load in the emulator and also be able to interact with that disk? Even if the disk is still kept in the museum, you can still give access to it digitally as you would in person. So the process there was looking at the Emscriptum library of how it did the file system mapping, and to essentially take that out and in its place put an LV-ROM call, again in JavaScript, that linked into the C code, so that when it said seek to this block and read these 256 bytes, we could then change that into a request that the Central Computing History servers could respond to and give back. And this allows you to split the two between what you need to experience Domesday through the browser to where the actual content is held and served from. Now, the downside with all this is that you think about the number of requests that are coming through, even though the latency of kind of the Laserdisc isn't, there's a little bit of there when it's running on your on the proper machine. When you're actually doing that over the web and having sequential access like this, it slows it down quite a fair bit. So the final part of the work was just to kind of implement that and put in a caching layer. Cache fixes most things, so that you have a larger block, a 64K block here of content that's taken from a request to the museum server, so you can actually have that in memory, and the hit rate of each of those 256 byte requests into that cache is sufficient that it runs very kind of quickly. It gives you that nice experience, so you can actually experience Domesday in the way that you like to imagine. So the endpoint, of course, is just one-click experience of Domesday, which is up. You can go to the Domesday site at the Computing History Museum's web server. It has the 3 discs, the northern side, the southern side, and the national discs as well. If you're in Chrome, you can actually make it full screen, and that's actually quite a nice experience, because then it takes it all away. You don't realize you're running it in a browser. And in terms of the way that the images are kind of worked on, it has the way of overlaying these things. If you've never used the national disk before, there's some really good kind of statistics that are projected onto maps that are worth playing with. And again, it is the Domesday experience. The approach has been to be as open as possible from the beginning. The code is open source. It's actually forked from the Stardot BeebEms, and it's if you go to GitHub, you'll find it there. It's under its own branch. It's the Domesday branch, and the kind of fantastic input and the help from Simon and the Domesday 86 people has been amazing. There's and Defini as well is looking at kind of how you can add things to the project, so you can actually have the best quality capture output from the digital and the analog content of the discs in a way that the material on the Centre for Computing History servers is the best material that it can be. So that it doesn't matter if you're physically visiting the museum or if you're virtually visiting the museum, you can actually have access to Domesday and kind of get to see what the project was about. And especially given the 2020 doing its thing, having that remote access to the museum is quite important, because it allows these activities to continue. So that was pretty much a kind of a whistle-stop tour of the approach to get the Domesday emulator working on the Centre for Computing History servers. I mentioned that BeebEm was chosen because it was close in terms of its capabilities, and I covered WebAssembly as this quite ubiquitous technology now that's in people's browser that allows you to take different types of existing software and run it in an environment that is emulated very, very closely, but it means you've got accessibility, and also there's a fair chance that being open, being standard, being maintained, this thing will then kind of continue to be supported years in the future. And I think that's an important output of this kind of work. So there are some resources. I'll share these on the forum as well. But with that, that's the overview. I'm kind of happy to answer any questions. And yeah, main thing is go to the website, try it out yourself, and help the museum with their efforts.
Okay, thank you very much, Rhys. That was interesting and very concise. We didn't have too many questions, but obviously I have a million of my own, so I can keep going as long as you like on this subject. It's close to my heart. So one of the things that that I was thinking about was that, it's fine to have this request where you have pictures being pulled back from the server whenever you request them. But outside of the standard Doomsday discs, the national and the community, there's actually quite a lot of video content that's in the other AIV discs. Do you have any plans or thoughts on how to expand this emulation environment to cover those types of discs as well?
Yes, definitely. So what you mentioned there of being able to seek to a frame and start playing, I think currently the way that it's working is pulling individual PNGs and displaying those. However, in the browser, you can actually have a seek into a video stream through kind of a specific time input to it. So if that looks like it's solid enough, and I think on most browsers now it is, it means you can actually move from a PNG loading system into a video seeking system, and then you're much closer to what the video player does in terms of it's holding a frame. You'll basically do the same thing. You say seek to this time and hold it, or seek to this time and keep playing it until you get to this endpoint, or I tell you to stop. And I think that'll be a closer match to the way that the player is constructed. It does mean changing a little bit of the way that the SDL thing is displayed on the web, because you're dropping an image display and basically putting a HTML5 video element behind it. And I think there's a little bit of work again to do if you're looking at overlaying. So you've got the transparency, so you may have to swap between the video and the images to make that work consistently. But yeah, that would be a good addition, because I think it is missing currently, and like I say, quite a few other discs have video as a more core element to what they do.
Okay, perfect. Next one is a little bit more of a generic question, really. I mean, clearly you've done a lot of work on the emulator yourself, a Herculean effort to get it up and running. Any advice or any sort of just knowledge, if there's someone watching this afterwards or watching this now that wants to join in, potentially wants to help implement something in the emulator or help out? I mean, just sort of generically, how can they help? How can they join in? Is there anything there for them basically to?
Sure, yes. So if you follow the links that are on the museum's website, it links through to the GitHub repository for the BeebEm emulator. There you can follow the normal GitHub kind of tooling of you can put an issue in, you can put a pull request in. The details are there to build the environment locally, so it tells you how to obtain Emscriptum, get that working, and the individual steps to actually recompile everything from sources to a working emulator on your own browser locally. What is missing, of course, is access to the Doomsday data. So either if you have your own kit, and that's great. Otherwise, one thing that I hope to have ready soonish is a kind of a test disk that will be part of that repo that basically gives you access to the core functions of Doomsday in a way that doesn't use a Doomsday system. So basically kind of a simple basic program that shows you how it calls the various functions. This will then help, so you can see how it seeks to a certain time on a video or plays a frame and does the overlaying kind of work, independent then of actually running Doomsday per se. It's more of a Laserdisc kind of LV-ROM system from there. But certainly if you go to GitHub, the link is on the museum site, clone that, work with it, and then raise issues or do pull requests. And then obviously on a wider scale, there's quite a vibrant Doomsday community, and participation on those is good as well, both on kind of Stardot, Doomsday 86, all of the other places there are good things to do.
Perfect. And I have to say that I've actually set it up myself, as you know, and if I can do it, I think anyone can do it, because web development is not really my thing. But I mean, I've following the instructions now that are on the GitHub. It's pretty easy to do. So, and there are some articles on there on the wiki now that kind of guide you through the basic setup. Okay. That's really it on the questions. I have just a comment from Ed S saying, and I'm just going to read it out: a great technical achievement, great explanation, and a very worthwhile public service. That's accolade indeed for you there, sir. And so on that note, what I'm going to do then is I'm just going to open this up to the floor, and if anyone has any questions for Rhys, then you're welcome to unmute yourself and ask away. And Rhys, before we jump into that, thank you very much for taking the time, sir. Really appreciate it. It's very interesting. So are there any questions for Rhys?
I've got one very briefly. Have you considered implementing the print functionality so that it gets a screenshot from the Domesday and prints the text? Because on the original system you can actually print. It'd be nice to produce a PDF.
Good point. Yes, because yeah, I hadn't considered that. That would be, I mean, capturing the print command. Yeah, I think that would be possible. Certainly, taking a snapshot of the data and generating PDF is pretty straightforward. All those are exist in browser land. There's a JavaScript library to do both of those.
Yeah.
Because I think having that would be quite good. I think also, yeah, you could probably do even more. Yeah.
Yeah, the original system had the option of printing out the stories, etc. But there was never any way of printing the overlay with the map. You could print the overlay, but you wouldn't get the map because that was from the Laserdisc.
Yes, of course, yes, because the BeebEm is restricted to what you can see, can't it? Yeah.
Yeah. Because in some of the material I'm scanning, I've actually got the overlays that have been printed on a colour 3D printer, but I have no idea what location they are in the UK.
Yes, I think because the browser sees everything itself, it's like the endpoint. So the process there would basically be punching through a print JavaScript function, hooking it into the C code in BeebEm, and then from there it could actually take the full picture of everything rendered exactly as you see it.
Yeah.
I guess the only thing that it can't do is trying to get the actual text out, because as far as the browser is concerned, it's just bits that it's seeing. It's not the actual text. But it could certainly do that. It could also extend that to a video as well. So you could actually capture a sequence of things. So if you're looking at, zooming into an area, reading an article and seeing some of the images and wanting to condense that into a very short video or a GIF, then that again could be done in the same way. It's like print to GIF, as it were. That'd be useful.
Okay, excellent question. So I have Phil M is pinging me saying that he has a question. Phil, would you like to unmute and speak away, sir?
Hi, yeah, can everyone hear me okay? Yeah,
we can hear you fine. And you look beautiful too.
Thank you very much. Rhys, the Inscriptum toolchain, can that, as well as compiling your C++, do you know if there's a way of compiling JavaScript as well for those, if that makes sense?
Yes, it can actually, you can interleave JavaScript and C code in the C source if you wanted to, and it'll actually do the right thing for you. And in fact, that's what I've added into the BeebEm stuff, because it was easier to keep it in context. So the actual compiler will kind of, through some if-defs in your C code, will see that this is a bunch of JavaScript. You can actually wrap it up then to say, this is the C function template I want you to use, and here's now some JavaScript that will understand some of that. And you can even give it kind of a bit of a byte array buffer, if you like, to get some data back. So yeah, it will actually do that for you. The interesting other thing,
Sorry, go on, carry on.
And the other thing it'll do as well is, if you do any kind of JavaScript coding, you'll kind of hit your head against everything is async. Normally, it's like asynchronous. It's do this, and when you're done, tell me, and then do this, and then you're done. And it's different to the sequential process that you normally code in, say, C or C++. So when you're bridging those two languages together, you need to be careful that you're matching the expectation in the same way. Quite a few things get confused if you are calling what you think is a synchronous call in C, but actually turns out to be asynchronous in JavaScript. Things get a little bit messy. So it has a wrapper that says, when you're calling me as a piece of JavaScript, even though I may be doing asynchronous things, talking to the network, whatever it is, I want you to block execution on the C side and make it look like this is a synchronous call. So it'll actually do that sync and async kind of matching up for you as well. And that's really useful. And again, that's done using a little kind of decorator in how you put that JavaScript code into the C. So yeah, really good tool chain to doing those things.
Yeah, so as well as sort of interfacing between JavaScript and C, is there some way of actually compiling like Node.js stuff, JavaScript stuff?
So you can. So if you're looking at kind of optimizing JavaScript to have, to be quicker, it doesn't necessarily target that specifically, but the whole everything around WebAssembly and what came before it, ASM.js, all of that work was basically adding types to JavaScript so that the JIT could just-in-time stuff in the browser could do its work. So the thing that made JavaScript slow is that it would JIT one piece of thing, but then when it came to run it again, because it didn't know what the type of the variables were, it couldn't match it and run it using the JIT output. It had to do the work again. So quite a lot of the speeding up JavaScript work is about adding types to the JavaScript stuff. And there are different additions and languages to kind of enhance JavaScript that does that, TypeScript and things like this. And that's the easiest way of doing it. Not necessarily kind of looking to compile JavaScript, as it were. I mean, I'm sure there are projects that do that, but from the way I see it, it's give type information to what you're doing in JavaScript, allows the machine to make things much quicker, and effectively that's all the WebAssembly kind of story is about, really.
Rhys, I wonder if I could ask you a sort of Doomsday related question on the. So I think first thing is the sort of copyright issue. So I gather that the museum has a sort of dispensation. So one of the things you've managed to do there is to help make this stuff publicly available, which otherwise it's rather difficult because it's all mired in copyright. Is that right? Is that the way that's working?
Yeah, I mean, again, I'm technology more than anything.
Yeah.
Yes, I think being a museum is the important bit in the story. And I think with a museum's charter, what it's meant to do, has in recent years kind of caught up a little bit with digitally what that means in terms of what you can do from what I understand. So the fact that this is the museum doing it from things that it has in its collection, serving the need that it has in to exist, are the things that have aligned up to allow this to happen. And hats off to Jason at the Centre for Computing History to basically say, we are doing this, and I think for all of us that's a big step forward. And again, it allows people to experience this thing, and it means that all of the work that is occurring, has occurred on archiving and preservation isn't lost. And I think that makes it's really important.
The other thing, if I could put as a favour really, could you perhaps throw back up that slide which showed the sort of life and death cycle? Because I think it is quite notable that, the original Doomsday book, of course, we can still read because it's paper. And then the effort of the BBC's kind of almost became technologically inaccessible. And the fact that it's got resurrected is a great story and a great success.
Definitely. So here's the screen. This actually was taken from a paper. Bring that full screen for you. So there was a paper done at the time, and it's linked on the page. You can see it there. The psu.edu link and the type to PDF. It covers off the approach of the original Chameleon work. And you can see the drop off of the availability of all the hardware and the technical stuff from the original release, and how Chameleon then took off. I guess I should maybe kind of follow that on a little bit. It's quite a persistent kind of story. And like I say, I think there's as much, from my point of view, interest in how the story of preservation kind of interest, as well as what was actually preserved, because there are a lot of lessons to be learned there. You know, the fact that it's just not one project, but many projects follow that same curve. There's yeah, lots to be learned from that process.
Yeah, I'd agree. It is fascinating. I think it's also quite fascinating that a sort of academic effort can flounder because of, you know, grant applications and people moving on and that kind of thing. And one of the things that a museum is it's an institution, and hopefully it's created in such a way that it can outlive any given individual. And that really helps in the long run.
Yes, no, definitely.
I was going to say on that note, when I first started university, one of our first ever lessons was sort of keep backups of everything, and sort of got everyone in the lecture theatre, and it's and whatever you do, don't store it on legacy media. Brought up some pictures of the Domesday discs and said, and no one can read these. And I stuck my hand up, and they said, yes. I said, I can read them. I've got a player and the discs. But ironically, they wouldn't let me try and archive the discs as my dissertation, on the grounds that they were copyrighted, and I would need permission. And it was, they just didn't want to sort of face any legal battles.
But I think one of the things that Rhys touched on, and it really lies into Ed's question, is that there is now within the British copyright laws a dispensation for museums. If it's something that's in their permanent exhibition or their permanent archive, which they have Laserdiscs, that means they are allowed to copy them and they have exemption from the copyright laws. So the Centre for Computing History can do something the rest of us cannot do. And of course, what that means is the work that Rhys has done, and you know, I dare say some of the work that we did as well on Domesday 86, means that you can now take advantage of that, because they have the legal right to take a copy and make it accessible, which is brilliant, because that's never been the case before.
Is there any chance we might be following up with the Volcano disc and Eco disc and Dinosaurs?
There is no dinosaur disc, but we have the volcanoes disc, the countryside disc. I also have, as part of this is more Domesday 86 than it is Rhys. Sorry, Rhys. We also have the Apple Visual Almanac, for example, on the Apple systems. So they're already archived.
I was going to say, here you go.
I meant, any chance that they would be getting rigged up through Rhys's work to made available?
Well, rather than just Ian showing off that he has some Laserdiscs, I thought that was way more interesting. No, Rhys and I are in an open dialogue about how to make that happen. I asked some questions in the background about the video stuff, but that's really just kind of leading Rhys on. Of course, we've discussed this. There's also a set of, within every GitHub, there's issues. So you can actually open and raise issues, and in there is discussion on how we will bring those things to the public, because clearly the Centre for Computing History has that in their archives too, and we have the technology to copy those and make it into digital form, which we can then load into Rhys's emulator to make publicly available. So suddenly a lot of things that weren't possible before are suddenly possible.
I was going to say, one of the things that I'm finding quite frustrating at the moment is the city discs, that we only know of 2 known copies. The Centre for Computing History have got an empty box with no discs. We managed to loan a set from Retro Computer Museum that is missing a disc, and we know that one of the original Domesday team donated a set to National Museum of Computing at Bletchley on the 25th or the 30th anniversary of Domesday, and they've lost them. And it's frustrating that we just can't find the last disc.
I've got 2 questions. First one, maybe Rhys and Simon, maybe not. I was just having a play around and looking at the pictures, and there seems to be something wrong with the scaling, whereby a diagonal line actually appears with steps in it. So I don't know.
Please explain, Rhys. for the umpteenth time we've had this discussion.
No, absolutely, yes. I think the getting the ratios correct and the sizes correct has been a challenge, and still is, to be honest. The kind of, first of all, is making sure that the capture captures the wider kind of output of what hits, the normal PAL output. The other one is that currently the way that the BeebEm resolution is set, it uses a 640 by 512 kind of buffer, whereas to actually get the correct aspect ratios, it should be 640 by 480. However, when you use that, the way that the BeebEm did it, it basically just chops a few of the pixels out, and that makes the text font look a little bit off. So currently it uses the slightly wrong aspect ratio so that you can actually read the text pleasantly. Obviously, BeebEm had a way of switching between the both, and I think that's the easiest thing to do in this case would be to say, well, look, you can choose your preference. You can have it as a correct aspect ratio, kind of more kind of correct kind of viewing thing, but you might lose a little bit on the font legibility. With Retina screens and everything else, obviously I should be making it kind of twice as high and twice as wide, and then you can actually then in between the actual pixels themselves do the correct smoothing on that. So that's probably some of the effects you're seeing. There are, and this is the great thing about the help from Simon and others, there are reference frames on Domesday that help with all of this in knowing how things should fit on the screen and where they are. So in other words, can you get the top and the bottom and both sides correctly? The kind of the test card equivalent, if you like. So part of the work in getting this disk image up on GitHub with non-Domesday material, but all the good things that you need to continue work is precisely to help with this. So on that disk will be those kind of the reference kind of test cards, as well as the sample programs to just sort of change the effect of displaying those things so that we can better hone and iron out these kind of glitches. I think for that iterative kind of development stuff, it needs a whole standalone thing, so you can just improve and test without actually going through and loading up all of Domesday just to see did that work. So yeah.
It's just that, yeah. I mean, it looks like a bug rather than just a weird scaling artifact.
Okay, send a screen grab of that. That would be useful to see. I mean, if
it's doing like, say, vertical scan line 1, 2, 3, 4, 5.
Yeah.
3, 4, 5, 6, 7, 8, 9, 7, 8, 9, 10, 11. So there's actually repeating with the offset. So looking at the maps, the text almost looks like it's got a shadow, and any roofs on skylines go up, down, down as they go up the diagonal. But yeah, just
a piece of advice, really. You have the ability within the GitHub issues to screen capture what you're seeing and attach those images to the issues. One of the things I discovered with Domesday 86 and the LD decode development, which is complex, is that it's better if you see something, whether you think it's a bug or you don't really know what it is, just raise it as an issue. The only thing the dev has to do at the other end of the GitHub is delete it. So it's better to raise more issues than you need than less. And sometimes it's not really clear to the dev what's going on without a nice picture. And maybe you think it's something we know about, but we don't know about it. So I mean, raising issues is always the way to get that to the forefront. So I mean, those are the two ways that you can really help open source projects. One is raising issues, even if you don't know how to code, and the other is pulling the issues and fixing them if you do know how to code. And those are the two ends of being involved in open source. I mean, open source isn't just about being a developer; it's also about being a constructive complainer, raising issues.
And if you raise an issue and the developer says, actually, that's not an issue because, and writes a reply, that's now documented, it's public knowledge. So somebody else who sees the same issue will come along and see the solution and won't need to raise it again.
Yeah, exactly. And I think LD Decode, we're tracking some 600 issues. So your life is easy at the moment, Rhys, but don't worry, we will make it miserable. But I mean, the images are being used in the current version of the emulator on the site, come from the LD Decode project. So they are the correct PAL images that are being put in. But clearly, I kind of threw them at Rhys, and this is just people working in their spare time. So it takes a little while between one thing happening and another thing happening. And you can either wait for it or you can join in and develop and make it a bit faster. Those are the two choices. But I mean, it is being done.
Sorry, is there how do you get to the GitHub from there, or did you post it separately, or is it the Doomsday GitHub?
It's not actually. It's Rhys's. I don't know, Rhys, if you want to pop it into the. I'll open the chat back up for everybody in Zoom, and you can just post it in there if you like. If I can find the button.
And the other question, Rhys, was not really Doomsday related, but if you're an old curmudgeon like me with some C-based Win32 stuff building in Visual Studio, is there a way to use WebAssembly with that?
Yes. So Microsoft themselves have got a whole, well, more kind of C-sharp thing, a Blazor environment that they target all their new fancy things with. So they're very much using WebAssembly as a first-class target. If you're doing, because quite a lot of the limitations are around the execution environment for things like graphics and the Win32 API. So there's no equivalent of those in WebAssembly or in ScriptDem. So really, it's if it's closer to a POSIX environment, it'll work. If it's Win32, then not that I've done much. I'm not sure if other people have, but as far as I'm aware, the same level of encapsulation of those APIs isn't there. But on the flip side, I do know that the Blazor project from Microsoft is a first-class thing. That's how they see things being developed. Certainly in an enterprise environment, you're targeting WebAssembly as the actual output. So there could be a path there from Win32 into that tool chain, not necessarily onto the script and POSIX side.
And is there just like a get a bitmap and draw to it?
Yeah, definitely. Yeah, this is so the whole SDL library is there, SDL2, and
without SDL.
Okay. Yeah, I mean again that current certainly on the ScriptDem side. So the ScriptDem is really how you get POSIX things into WebAssembly. If you're doing things there's an OpenGL layer as well. So again, that's the other mechanism you can use for graphic outputs. But those are the primitives you have to play with, and obviously libraries that build off top of those will then compile into it. But there's no kind of DirectX or anything kind of that level.
Okay, that's fine.
Thanks, Richard. We've got 2 more minutes before we hit the top of the hour, and I've just got a ping from Phil saying that he had another question. Phil, are you there still?
I'm still here, yeah.
You are the last man of the day. Go for it.
Okay. The video from Doomsday, in one of your block diagrams, you were showing like 64K cached downloads from a server. How well does that work with the video from for Doomsday?
Yeah, but quite a simple answer. It doesn't. So there's no video support currently in the system. It is the frame images and the LV-ROM data.
Right.
I think on the video side, it'll effectively be video streaming from another source off the museum server itself, and you're effectively saying, play this video, go to this frame and pause, or play for a certain number of frames or time linked to those frames. So yeah, again, I did the easy, simple stuff and didn't implement the video in this version. So
I was just thinking for a local HTML file, if you could have a kind of local version of the thing. I mean, just do a quick comment as well. I'm totally with you on the browser thing. I mean, there's no download, there's no installation. It's browser and platform independent, so it's a great way of doing it. But one of my emulators, I make it so that it can run locally as well. If you had maybe local data files for video, do you think that would be possible at some point?
Yes, definitely. I mean, there's two things that work there. There is a file access API that is coming into the newer browsers. But there's also another project which is called Electron. And this allows you to take a web project, a JavaScript, HTML, whatever bundle of things you have, and actually create a local application. And that has Node.js at the backend, so you can actually talk to your local file system. I think JSBeeb's just done a wrapped version of theirs in an Electron app. And again, that's quite a nicely maintained project. It's got easy guides of how you take an existing project and wrap it up. And then because it's running locally, it's got access to everything. So you can load and save files as you wish locally then. So that's an approach that you could take for things that, that are better suited for local access.
That lets me crowbar in a sort of sneaky question about, would you be interested in a collaboration maybe on a DOSBox stuff with the Genlock MIC card things that we were talking about earlier, maybe a DOS-based version based on your experience with getting the BBC LDV.
Sure, yeah. I'm always happy to help, and I think the DOSBox thing is the background to. I don't know if you remember. I showed a screenshot of the Microsoft Flight Simulator. That's actually I think it's DOSBox compiled into WebAssembly with a bit of a boot script injected in that maps a startup kind of disk that loads the flight simulator for you. And again, that means you can just click once and you're running, that software straight away as it was. So yeah, I can definitely.
I think it was that triggered the question. Actually, that one screenshot that you were saying, but that would be good for a locally running thing, for running video, especially with some of my old interactive video PC-based stuff. That would be a good way of doing it before making sort of an FPGA ISA slot based solution, is to do it in software in the way that you're doing here. That'd be brilliant if you'd be interested in collaborating with that.
Yeah, certainly happy to help where I can, and yeah, quite often that's pointers to things as well that I know other people are doing. So there's I did check the DOSBox thing is open source, so being able to pull that in and get something started off should certainly be okay to do. So
yeah, really good news. Thanks.
Awesome. Well, that is the end of the session. Obviously, we have a little bit of time after this for some projects and troubleshooting, I believe, before we go into lunch. But before we do that, thank you very much, Rhys, for your time and effort in doing the presentation. Greatly appreciative. It was really interesting.
Great. Thank you.
Thank you.